Hi everyone. So I'm not going to say too much in this particular video file since I already referred you to another video that pretty much gives the context of this particular section of the text. In other words, what we're trying to focus on here isn't just understanding the current opinion of what the model of the atom should be like, as much as to understand and appreciate how that model developed. And the video that I referred you to on YouTube is an excellent source, though it might have a little bit too much information in terms of what it is that we're actually trying to learn in this particular part of the chemistry curriculum, and so I just wanted to put it into context. The important thing to keep in mind when we consider the model of the atom is, again, initially the picture of the atom was very simple. Just like I'm showing you on this slide, basically it was considered to be just a fundamental particle or a sphere. So again, essentially the atom was thought of as a fundamental particle, which means that it couldn't be subdivided any further, and obviously Dalton had no idea that atoms contained any parts within them. Right? Now, as the video goes on to say, basically, eventually what happened is when Thomson came along, he was able to prove that the atom actually has parts within it. Specifically, it has particles that are charged, such as the electron. Now, obviously, as the video goes on in great detail to mention, we know that atoms are neutral. And so since atoms are neutral, Thomson thought, well, there must also be a source of positive charge in the atom, and he thought, well, since I only know that the atom is, again, something that we consider to be sort of a teeny tiny microscopic sphere, the simplest way for me to incorporate there being negative charges is to just randomly sprinkle them throughout. And since I know that there are positive charges too, well, I'm just going to assume that the rest of what we consider to be the atomic sphere, if you will, that this atomic sphere has a positive charge, which is why the sphere in the diagram here has that plus sign within it. Now, again, that's what most people actually agreed was probably the most reasonable model based on Thomson's data. However, we know that that model was relatively short-lived because eventually Rutherford came along and using his gold foil experiment, he was able to actually prove that in the center of the atom, there's this dense region of positive charge, and that this region also contains most of the atom's mass. And that region is the nucleus. Okay? Though, if that's the case, then if the nucleus contains the positive charge, then he sort of felt that the electrons must be outside of the nucleus, and so he pictured the electrons sort of zooming around on these circular paths, which he called orbits. Okay? And so that's really the main point of what I want you to take away from the video that I actually referred you to in this tutorial, in addition to this pre-lecture tutorial that I'm giving you now. Essentially that the picture of the model of the atom sort of evolved or changed over time. Basically, again, from just being a fundamental particle that was considered to be indivisible, okay, to Thomson's model, once the existence of the electrons were proven, then we sort of randomly sprinkled those regions of negative charge, or the electrons, within what we consider to be the positive sphere of the rest of the atom. And then from there, once Rutherford did his experiments, then we were able to prove that atoms have nuclei, and that outside of these nuclei, we have these electrons zooming around in orbits. Now, as the video goes on to say, past the point that I asked you to watch to, there is a whole other model in place now, and obviously the atomic model actually evolved even further after Rutherford's model, but we're going to discuss that later on in the school year. So again, if you have any questions about anything you watched in this video or the companion video to this tutorial, then just let me know. Otherwise, we'll see each other in class tomorrow. We'll discuss it some more and answer some additional questions related to this topic. Okay, have a good night.